First question. The major floor loadings in storage are caused by the object shown. Each force acts through its respective center of gravity, G. Locate the center of gravity, X, Y, of all these components. Okay? By doing this, let's determine first uh, the, the weight on the X bar, the Y bar by feet, and the X bar times weight and the Y bar times weight. For solving the center of gravity of X bar and Y bar, um, so the X bar is X bar is equals to the summation of X bar times weight or over the summation of weight, which is equals to um, 108,000 over 3,500 equals to 30.86 feet or 31 feet. And for Y bar is equals to the summation of Y bar times weight over the summation of weight, which is equals to 57,400 over 3,500 equals to 16.4 feet or 16.0 feet. And the final answer for X bar is 30.86 or 31.31 feet. And for Y bar is 16.4 feet or 16 feet. For parallel axis turn, the polar moment of inertia for the area is JC 674 meters to the fourth. About the z-axis passing through the centroid C, the moment of inertia about the y-axis is 296 meters to the fourth, and the moment of inertia about the x-axis is 970 meters to the fourth. Determine the area A. So first, let's apply the parallel axis turn to determine the centroidal axis of x. First, we have the JC, we have the y-axis, the y-axis, the x-axis. So first, Ix is equals to 970 and equals to centroidal of x plus the area and then the distance of 3 meters times the distance of 3 meters squared. So Ix, centroidal x is equals to 970 minus the area times 3 squared. So then we know the centroidal of x or the moment of inertia of x. Then let's determine the area. So for area, JC is equals to 674 and it is equals to Ix here. Ix, which is our Ix is equals to 970 minus A times 3 squared plus as 296, which is the moment of inertia of y-axis. So area is equals to 65.78 meters squared, or area is equals to 66 meters squared. For composite area problem, let's determine the moment of inertia for the shaded area about the x-axis. So for the segments, every segments, we have the area, the distance, the centroidal x-axis, the area times d squared, for us to determine the x-axis. Determine the x-axis, which is the moment of inertia. So first, let's find the area, distance, and centroidal x-axis, and the area times d squared. So we found the area, the distance, the centroidal x-axis, the area times d squared of every segments we have. So for the final, we have to plus the centroidal x-axis plus the AD squared of every segments to find the moment of inertia of every segments. Okay. We find the moment of inertia of x-axis of every segments we have. To determine the total moment of inertia of x-axis here, so Ix is equals to the summation of Ix, which is equals to 5521.47 meters to the fourth, or 5521 meters to the fourth. And this is the final answer, or the summation of determining the moment of inertia about the x-axis. For mass moment of inertia, the problem is the fat rods have a mass of 10 kg per meter. Determine the moment of inertia of the assembly about an axis perpendicular to the page and passing through point A. Here is the problem. This is the rod, the tube rod, and their center of gravity here. So first, let's find the mass, or MI. It's the mass of 10 kg. 10 kg per meter. It is times to 100 meter, which is equals to 1000 kg. The total mass of one rod. So to find the moment of inertia, first let's use the formula of mass moment of inertia, which is the Ig equals to 1/2 times mi L I squared, which is the 1/2 of mass times the length of the road. So to determine the axis perpendicular to the page and passing through point A, so Ia is equals to the summation of ig plus mi, or mass times distance squared. This is the distance of to the center of gravity, distance of center of gravity. So it is equals to 1 over 12 times 1000, 1000 for the mass, and times 100 squared for the length, plus 1000 times 50 squared, the mass, and for the distance to the center of gravity, or the centroid. So plus the 1 over 12 times 1000 times 100 squared, plus 1000 times 100 squared. So it is equals to 141,66666, or so 0.67 kg times meter squared, or 14,166,666.67, or IA is equals to 14,166,667 kg, or kilogram times meter squared. So the final answer is this. For product of inertia, let's determine the moment and the product of inertia about the x and y axis, also the principal moment of inertia. So first, this is the problem. Our length of the rectangle is 4 meter, and 6 meter. This unshaded space is the empty space of a rectangular. So to find the ix, or the moment of x, ix equals to ix plus a dy squared, which is equals to ix equals 1 over 36 times 6 times 4 cubed, plus 1/2 of 6 times 4 times 1/3 1/3 of 4 squared, equals 32 meters to the fourth. For y-axis, so iy, or moment of y, is equals to iy, what's the total of y, plus adx. There's an adx squared. So iy is equals to 1 over 36 times 4 times 6 cubed, plus 1/2 of 4 times 6 times 2/3 of 6 times 2, and it is equals to 216 meters to the fourth. And then to find the product of inertia, in our book of page 550, we find there that integration with respect to x and y axis, ixy, which is equals to base squared times h squared over 8, and it is equals to 6 squared, which is our base. Our height is 4 squared over 8, which is equals to 72 meters to the fourth. So this is our product of inertia for 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 the principal moment of inertia, which is here. The principal moment of inertia, to find that, using the formula of I max minus over minus, which is equals to Ix plus Iy over 2 plus or minus with the square root of Ix minus Iy over 2 raised to 2 plus the product of inertia, which is the Ixy squared. Okay. So our Ix is 32 plus 216 over 2 plus or minus the square root of 32 minus 216 over 2 squared plus 72 squared, and equals to 124 plus or minus 116.8. Let's just add and minus this problem, this number here, add this number here, and then we can get the Imax or the maximum, which is equals to 240.8 meters to the fourth, and our I minus or the minimum, max and the minimum, which is 7.2 meters to the fourth. And this is our final answer, determining the moment and product of inertia about the x and y axis and the principal moment of inertia. And here is our answer for product of inertia and for principal moment of inertia.